Okay, so in this problem we are going to be using a scale drawing or a scale model to solve for the actual height of an object. So let's read the problem and we'll see where we need to go from there. So it says, as part of a city building refurbishment project, architects have constructed a scale model of several city buildings to present to the City Commission for approval. The scale of the model is 1 inch equals 9 feet. So I am going to write this down. 1 inch is equal to 9 feet. So this is my scale, and I'm going to just write it off to the side so that I can have my key information out there. This is a good strategy for solving word problems like this. And now I'm going to continue reading to see what the problem is asking me. So it says the courthouse is the tallest building in the city. If it's 7.5 inches tall in the model, how tall is the actual building? So we're trying to solve for how tall the actual building is here. So if you'll recall from class, we need to make a ratio that is going to be model over actual, and then that is going to be set equal to scale. So now I've created a proportion. I have model over actual is going to be equal to scale. So this is going to be our equation, if you will. This is going to be our model for solving all problems like this right here. So model over actual. The model I know is 7.5 inches tall. And then the actual is what we're solving for, so that's going to be our variable. And we're going to set that equal to our scale, which is over here, which is 1 inch to 9 feet. So 1 inch to 9 feet. So with a problem like this, I need to cross multiply. So I'll have 1 times x, right here is just x. And then I'll have 7.5 times 9, which I'm going to do with my handy dandy calculator, and that's going to give me 67.5. So I have 67.1/2. And now I need to decide what my label is going to be. Well, if you'll look at our proportion here, I have inches over feet. If I want to write that there. And then I have inches over feet. So model over actual equals our scale in inches over feet. So since my model was in inches, which was my numerator in both fractions, my actual is going to be in feet, which is my denominator in both fractions. So since I was solving for my variable as the denominator, my unit of measurement is going to be feet. So my final answer is that the actual building is 67.5 feet tall. So now to try one more problem like that, that's just slightly different, we'll flip over to the next page here. So we have the same problem up here. It says that our scale is 1 inch to 9 feet, so I'll write that out again, 1 inch to 9 feet, and that's my scale. And then I need to read the rest of the problem now. So it says the City Commission would like to install new flagpoles that are each 95 feet tall. How tall are the flagpoles in the model? So the last one we solved for the actual. Now this one we want to solve for the model. So again, remember that our equation that we're going to always use is model over actual. And we'll set that equal to the scale. So there's our equation. And now I'm going to plug in. So how tall are the flagpoles in the model? Well, we don't know what the model is, so that's going to be our variable. And we're going to put that over the actual height of the flagpoles, which are 45 feet tall. 45 feet. And then we know our scale is over here. It says it up there. It is 1 inch to 9 feet. So I need to cross multiply. 45 times 1 is 45. And that's going to be equal to 9 times x, which is just 9x. Now I have a one-step equation here. I need to divide out my 9. So 45 divided by 9 is going to be 5 equals x. And I need to have my unit of measurement, right? So if my numerators, my actual was feet, then my denominators were feet, then my numerators up here on the top are going to both be inches, so the model is going to be in inches. So then it's going to be 5 inches is the final answer.